In this program, we're going to begin looking at what are called the manipulators for the C++ language, and that will help us to format the output for various things, numbers or whatever. We begin this lesson with a skeleton of a program, which you can see already on the screen. And these are things that should be already apparent to you and easy to use. We've already looked at the cin and the cout in a simple form. Over on the right hand side, you see we have the name of the file over here in our Solution Explorer, and you'll always see that. And in the middle you'll see the code. And what I'm going to do, as I will in future videos, is to make more space for us to use here by closing down the panel that has a Solution Explorer. And I will make the screen resolution a little higher to 125% so that it is more readable. As always, we will look at the header information where we have the pound includes, and this time make sure to notice that we are using the input-output stream, the IO manip, which allows us to use these manipulators, as they're called. And I've also added the pound include for strings because we're soon will be looking at information that is non-numeric, so words and sentences and things like that. We still have the beginning, integer, main, void, and so on. We have declared as a type double the variable pi, and it's been initialized to this value here. We're writing out to the screen using cout, the string constants output options, and pi in scientific format. So the first manipulator that we're going to be looking at will be, several of them actually, we'll be looking at the scientific setting as well as fixed. You can see that I have included already just some comments spaced through the program to indicate what we're going to do, and then we'll fill in the C++ statements to actually do that. Alright, well, let's go up and let's do the set scientific. The way that you use these manipulators, for the most part, and you can use them with cin as well as cout, but you'll see them mostly on the cout side. So we'll do a cout, and instead of actually outputting something to the screen, we can use a manipulator to change the format at this point. So if you want to see something in scientific notation, you do cout and the word scientific, semicolon. Okay, so that just means that future output will be in scientific format. Now, to see that, let's use cout, and let's output pi. Okay, uppercase pi is the name of the variable, and then we'll just use an end line here. And in fact, I'll use two of them to skip 2 lines. Alright, now at this point, let's just go ahead and run the program and see what it looks like. So I'm going to build it. The build was successful, so now let's run it. And let's look at the output. Okay, let's scroll down in the code window, and then we'll bring the output window back up. Now, notice the output here. We did cout scientific, and then we output the variable pi. And notice that we have pi in scientific format, that's output, and we have 3.14159 e to the plus 000. So that is the scientific format. It gives you a fraction and an exponent. So if you want to see your output in scientific notation, then you just use the scientific manipulator to do that. Now let's continue. Let's go back to our code window, and now let's change the output format to fixed. Now this is still going to be a real number output. We'll have a whole number, we'll have a fraction, but it will not have the e part, the e representing the exponential notation for this. If you want to change your output to fixed, as you might guess, you can do cout and you pick fixed and then semicolon. Okay. So you don't see anything on the screen when you do those. It just changes what future output is going to look like. So with fixed, now let's output pi in fixed format. Okay, let's do cout. And let's print, first of all, a string constant here, pi in fixed format, a double quote to terminate the string constant end line, and then we'll do cout, and we'll print pi and end line. 2 end lines to skip 2 spaces. Now, so this will show you scientific notation, what it looks like, as well as in fixed, so we can see the difference. Okay, let's go ahead and build this. Build was successful. Let's run it. And now we have the output. Alright, so here we have the output options, pi in scientific format as we had previously, and now we have pi in fixed format. So we have 3.141593. Now it's interesting, and I should point this out. When I declared pi, look at all the digits to the right of the decimal. 14159256. That's 1, 2, 3, 4, 5, 6. That's 7 digits of accuracy over here on the right-hand side. But when I print those out using either a scientific form or if I used fixed, then that is rounded to 6 places. So 141593 in both scientific and in fixed. And that is the default. If you do not specify something different, and we'll see how to do that shortly, then you always get 6 digits to the right of the decimal. So let's close this window and continue with the example. The next thing we're going to do is to look at setting the field width and the precision. We'll print out to the screen cout pi in fixed format with width and precision set. Now, here we're going to designate 4 digits to the right of the decimal. So we'll use another manipulator for that. So we're going to do cout, and the manipulator is called set precision. Okay, set precision, I need to spell that correctly. And then in parentheses, you indicate how many digits to the right of the decimal that you want. Okay, so I said that in our comment here that we want 4 digits to the right of the decimal. So we will do cout set precision to 4. Then we will output the value for pi. And let's put our 2 end lines as we've done previously. So this will give us pi, and we will see it with 4 digits to the right of the decimal. So doing each one of these in turn, let's go ahead and build this program. The build succeeded. Let's run it. Now we have all of the stuff that we had previously, but the last thing that we did was to set the precision to 4. So now you'll see that we get 3.1416. So this is how you can control the number of digits to the right of the decimal. You use set precision. This will stay in effect as long as you continue to output values. Once you set something, you can set to fixed, you can set to scientific, you can set to precision, then those are going to remain in place until you change them to something else. Okay, so we had fixed, we had precision of 4. So that will stay that way as we continue. Now the next thing we can do is we can designate how many places, positions to print on the screen. So we're now going to see how to make the output appear right justified in a 10-space field. It'll still have a precision of 4, but it will print in 10 positions on the screen. Okay, so to do that, we do cout, and we do a set width, SETW, and then in parentheses, then you indicate how many output positions you want. So we do a set width of 10, semicolon. Then we will output the value for pi again, cout, pi, and 2 end lines like before. Let's build this and run it. The build succeeded, so let's close this panel and let's look at the output. Okay, I've got too much going on here. Let's close this down. I clicked the wrong thing. That's what I want. Alright, so you can tell then that the last thing we did was we set the width to 10 and then we wrote out the value for pi. Now if you look at the window, then you can see that the 3.1416 is now has some space over on the left hand side. So the numbers themselves, we have 1, 2, 3, 4, we have 6 numbers including the decimal, and then to the left we have 4 spaces. So you can easily tell from up above the output that we had, there's 4 spaces over here. So by setting the width to 10, then the number is output in a 10 space field, right, justified. And since we set the precision to 4 earlier, then it remains 4 here. Now, let's change things up a little bit. So we want to now use a field width of 6 with 2 digits to the right of the decimal. Right? So we need to do the manipulators again. We can do C out, and we want a width of 6 with 2 digits right of the decimal. So let's do a set precision, and we want to make that 2. And you can put these on the same line. I've been just using separate lines, but you don't have to. You just have to have the insertion operators in between. So you can set the precision to 2, and you can set the width on the same line using a set W here. And that width is going to be 6, semicolon. Then I'm just going to copy the C out statement we've used already. I don't want to type that in again. So then we'll set the precision to 2, the width to 6, and we'll output the value for pi. So let's see what we get this time. Build succeeded. Execute. Looking at the last output, then you'll see that indeed, if you count those spaces, we have 4 for the numbers, including the dot, and then 2 spaces to the left, and the precision now is set to 2. So you can control your output. You can format your output, if you prefer, by using the set precision and the set width commands. And all of these have been output using the fixed notation, which means we don't use the exponent, we just use the numbers. Now, for our final case, let's try this. Let's try to do a width of 6, but we have 6 digits right of the decimal. All right. Now, this will obviously be a problem because if we have 6 digits to the right of the decimal, then we don't have enough spaces if we only have a field width of 6, because we still need to print out the 3 and the dot. So what happens if we try to do that? So let's do C out, set precision to 6, and we will do a set width to 6, indicating that we only want 6 print positions, semicolon. And then once again I'll copy this C out for pi because it'll be exactly the same. Alright, so in this case then what will happen? Well, we could get an error or something else good could happen. It turns out something good happens. So let's go ahead and build it. That was successful, so let's run it. Here we see the output. Now notice with the last case we wanted a field width of 6 and a precision of 6, but instead what we get is a total number of 8 print positions. So 1, 2, 3, 4, 5, 6, the dot is 7, the 3 would be 8. So the lesson here is that if you should set the width to be some value that is too narrow, then the system will automatically override that and it will print out your number using the necessary print positions. One final comment about the set width manipulator. The set width manipulator is only effective for the one single thing that is printed afterwards. So unlike set precision and fixed and scientific, the set width manipulator has to be used prior to every variable if you want to set the width to something other than the default. So be aware of that. We'll see that in coming lessons. Okay, so that concludes this video, which talks about using the some of the manipulators. There are many others, but the manipulators: scientific, fixed, set precision, and set width.